Hello again. Today we're going to go over 5.5, which is the fundamental theorem of algebra and the rational root theorem. They go together like peas and carrots. So the gist of the fundamental theorem of algebra is if you got a polynomial equation, the number of solutions is going to be the highest degree. So I'm going to highlight the two problems that we have right here, number 1 and number 2. You can see on number 1 is 3x to the 5th minus 5x to the 4th plus 7x minus 9, but the highest degree is 5. So that is the total possible number of solutions. We can have up to 5 solutions. For number 2, we can have up to 6 solutions because the highest power is the 6th power. And that's pretty much all that the fundamental theorem of algebra is we state how many times we could cross the x-axis in this case because we're setting them equal to 0, and the first one could cross it 5 times and number 2 could cross it 6 times because the power, the degree. So we use this and the rational root theorem to decipher whether or not the 5 solutions that we could have, if we can find 1 or 2 or maybe all 5 of them, if it's nice enough to factor or to use synthetic division on. So the rational root theorem, its purpose is to find the possible roots, or in this case rational roots, and a rational number is a fraction or could be a fraction of a polynomial with integer coefficients. So we have to have just a normal polynomial with numbers in front of each variable and hopefully a constant, because that's really a necessary feature of this. So first and foremost, let p be a factor of the constant term. So I'm going to use this right here. P goes on top of our fraction, p over q, and I'm going to highlight our constants on both 3 and 4 here. So I highlighted them in yellow so you can see it. For number 3, we have -3. That is our constant term, and we're going to be finding factors or multiples in this situation. So now we're going to look at q. Q must be a factor of the leading coefficient. So that is the highest power, whatever numbers in front of the highest power, or multiplying the highest power. So in this case, we have p over q, and then all possible rational roots of the polynomial must be satisfied by this p divided by q. And so this will get a little confusing if we have an a value, which we do for number 4, or a q value I should say. But let's take a look. For p value of number 3, we're going to look at the factors of this 3, or -3. -3 can be 1 times 3, and either one can be positive or negative. So we have 2 choices, or in this case actually 4 choices. 1, positive or -1, and positive or -3. Now q, since this is 1x cubed, we only have 2 choices. The multiples or factors of 1 are just positive and -1. So I'm going to run through number 3 with you, just so we can get situated. We're going to take all of our p values and divide them by our q values. And what you're going to see here, I'm going to list every single one of them out. +1 divided by +1, that's just going to get you 1. +1 divided by -1, well, that'll get us -1. And we can flip those around and that'll get us the same thing. Again, a -1 divided by a -1 is +1. And we just roll through +3 divided by +1, well, that's going to be 3. And then we have +3 divided by -1, or you could have -3 divided by +1, vice versa. We're going to get -3. So you can do that. You can do it however which way you want. I think about it logically, and I just say, hey, what is every number divided by 1 and -1? Well, I should get ±1 again, divided, and ±3. So this gives me up to 4 possible solutions. Now, with the rational root theorem, we have to understand that it doesn't mean that all 4 of these will work. One of these could work, or 2 of them, or 3 of them, or none of them. So we have to be very cautious here. And I'm going to show you a couple different ways, and we're going to go back to our homework and look at the different ways that they are offering us to figure out whether or not we're going to have certain roots or factors. So let's test this out for number 3. Let's test it out. For the real zeros, I'm going to choose -1 to test. And it says to determine if a possible root is really a root, you need to plug it in, or aka substitute it in. You need to plug it in into the equation and see if you get 0. That's why it said equal to 0. So I'm going to use this original equation, which is going to be 1x cubed plus x squared minus 3x minus 3, and I should set it equal to 0. So this is my whole premise here, is I'm just trying to set it equal to 0 and see if it works. Now I said I'm going to try -1, so I just substituted -1 into each one of these. -1, -1, -1. I'm going to use my math skills. So -1 cubed is -1, plus -1 squared, which is 1. -3 times -1 is +3, minus 3. And is this equal to 0? I think so. This is 0 plus another 0, and that's equal to 0. So -1 is a root, or a factor, right? It's something that works here. And we can use this in a multitude of ways. We could check this with synthetic division. We could look at the graph, and that's what I'm going to do here. I'm going to take a look and see if any of our other solutions will work quickly. And I'm going to do this by looking at our graph here. And I have this graph, and I looked at it on Desmos. So here is your x cubed plus x squared minus 3x minus 3 is equal to 0. And you can see that -1 is a solution. But I want you to look at the other two. These ones stop at 7.732, but that's not true. These are actually irrational numbers, and we're not going to be able to solve these numbers any further. If you were to use synthetic division and check that, you would see that we would end up with a quadratic that requires the quadratic formula, and that's okay. We'll still end up with 2 other solutions, or 2 other x-intercepts, but it's going to take a little bit more work. And that's what we're expecting you to do when we get to the next section. But substituting in numbers is not super difficult, so you should try it. Let's talk about the next one, though. Let's do this work again one more time. I have p values that are factors of 8, and we have to remember the numbers that multiply to 8 are going to be 1 and 8 and 2 and 4. And we can have sets of positive numbers or sets of negative numbers. So we have a lot of choices here. So I'm going to put plus or minus 1, 2, 4, and 8. All of those are going to be positive or negative. We now need to look at the leading coefficient, which is 2. And there are only 2 factors of 2, or 2 multiples of 2, which are plus or minus 1 and plus or minus 2. So like we discussed before, we can take a look at plus or minus 1 as our divisor. So this is our Q value. Any of the numbers 1, 2, 4, and 8 divided by 1, whether it be positive or negative, will still get us the same original number, which is plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. But we should do some math behind dividing everything by 2. So quickly, we've taken care of the plus or minus 1 for the Q value. We now need to divide 1 by 2. So we're going to end up with another factor, or another possible root, I should say, of 1 over 2. But if we divide 2 divided by 2, well, that's just going to get us 1. That's just a repeat. 4 divided by 2, that's another repeat of plus or minus 2. And then 8 divided by 2 is plus or minus 4. So we end up with some repeat answers. We don't relist them as possible answers. They're already given to us. So I want us to count this out. This is, let's see, 2, 4, 6, 8, 10 possible solutions. So 10 solutions that are possible. And we know from up above that we really only have 3 real solutions that are available. So this is now playing a game of guess and check, and that's what makes this kind of tedious. So you can go through each one of these. You can put this into a calculator. You can, if you have a graphing calculator, you can actually program it in and make it a lot easier and see if any of these solutions work. You would test all of them. So you'd put all of them in here, and what becomes more and more difficult is when our A values not something easy like a 1 or a 2, if it's a 5 or 7, or if it's something crazy. But we'd have to test all of these values, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 1/2. All of these values will have to be tested. And I'll tell you right now, none of these values actually work for this one. So let's take a look at the graph and see why. If we zoom in on this graph, we can see that none of these values are going to be even close to plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, or plus or minus 1/2. And that's just the unfortunate part of this, is sometimes we strike out. Just because the fundamental theorem of algebra says that there's going to be 3 solutions doesn't mean that our rational root theorem will actually get us 3 viable solutions. And you can kind of tell just from the beginning, if you're looking at it, if you were to do factoring by grouping, you can see that there's nothing to take out as a common factor from the second group besides a 1, and it's not going to leave us with much. So I want you guys to heed this advice just a little bit. It's not factorable by grouping. There are going to be some tricks that you have to look at before you analyze this and just use brute force. So before we leave here today, make sure that you go back and pause the video when you need to pause it, watch it a few times at 2x speed or 1.5 speed. But here are the questions that we're asking for on the homework. Identify how many total solutions there are, or real or imaginary, for each polynomial. And that's going to be using the fundamental theorem of algebra. So that's just looking at the highest power. Then we're going to calculate the possible number of roots. So that's going to be using the RRT, or rational root theorem. That's just telling me using the p-value, which is the constant, and the a value, or the leading coefficient, which is the q, telling me how many solutions you possibly could have. And then C, I want you to find all the possible roots. You're going to have to use different strategies: rational root theorem, synthetic division, factoring by grouping, quadratic formula. There's lots of different ways to do this, and that's what makes this Algebra 2. If you have any other questions, please feel free to email me or one of the other teachers, but I hope this video has been informational for you.